Hello, physics students. We're going to talk about electric field line rules and then do problem 10. So electric field line rules and problem 10. So what we have here is we have arrows. First rule is all arrows will point this way a small positive chest charge would go. They can connect between the two lines, that can connect between the two if the charges are opposite in sign. So let's just do a what if here, a little scenario. If we have a positive charge, unknown size, we have a negative charge. What are these lines going to do? So the way a positive test charge would go, well, let's draw a line connecting the two. And a couple lines. So if I released a small positive charge, where would it go if I set it between these two? It would be, this one would shove it this way and this one attract it this way, right? So this way this would go would be this way. Positive charge would go this way. Okay, what if we connected it with another one here? And another one here? Once again, those lines here. You could also have this go out. What if we had this one go out like this? And another one go out like this. Or actually, we'd probably go like this. Let's go. Let's erase that. I got Avengers in the background. It's kind of hard to think, and the kids are talking too. So this would go maybe like this, and they don't all have to touch. The ones directly between here, this one go like this. Maybe we do another here and another here. There we go. So, all right. What if we had, say, two positive charges? What would happen? Well, this would force the positive charge this way, but this kind of forces it this way, so these things would go like this. So these lines would cause a positive test charge to do kind of like this. Okay, and we could have two more like this. And then, you know, these things with a positive test charge put over here, it would fly out this way. A positive test charge over here would fly out this way. And guess what? If I had two negatives, it would be the same diagram as this, the same electric field diagram as this. Okay? So that's what this one means. Okay, the greater the number of field lines attached to the charge, the stronger the charge. So, and look at this, how many field lines? 1, 2, 3, 4, 5, 6, 7, 8. Well, how about this one? 1, 2, 3, 4 attached to this one, right? So which of these two has the larger magnitude of charge, larger magnitude? This one. And in fact, by this second rule, the second part to this rule is the relative size of the charge can be found when compared to the other one by comparing the ratios. What is it? It's 8 to 4. Well, that's a 2 to 1. So how much stronger is this positive charge? It's twice as strong. Now, we don't know exactly what it is unless we knew one of the charges of the two. Then we could calculate it, but we know that the positive charge is, in fact, twice the size, the magnitude, meaning absolute value of the charge, as the negative in this case, because there's 8 lines touching it compared to 4 lines over here. What about this one by the same rule? We have 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 6, and 6. So those will be equal in magnitude. So those will be equal by rule number 2 there. And like I said before, if these were both negatives, you would have a similar diagram. Now, the number of lines could be different, but all right. Now, the greater the density in the area, the greater the electric field strength in that one. So the greater the line density. So where's the line density here? In between these two, there's more lines than anywhere else per unit of area. So the field strength is the strongest here. So you could say strongest between the two, right? Now here it's kind of hard to decide, but you would still have strong field strength in here. Well, not right here. Like this is empty space, but like here, okay, and you got some strong field lines there, kind of got some strong field lines there. So yeah, the greater the density, the stronger the electric field in that area. All right, so let's answer number 10 now. Okay, I already have actually, so this is unit 11, problem 10. Here are the answers, but we'll go over them. Let's look at our diagram. Q is pot 1 is positive. Well, look, if you look here, which way are the arrows? They're pointing away. Well, the arrows by rule 1 I just discussed is the way a positive test charge would go. Well, what would force a positive test charge away from it? Another positive charge. So that's why it's true. Okay, a negative, that's a negative sign, a negative charge at A, this is at A right here, at not, it's right here at this letter A here, would accelerate to the left. Well, the arrows point the way a positive test charge would go, and the positive arrows are going to the left. So no, a negative would go opposite. A negative would go to the right. So that's why this one is false, and as you can see there. Okay, the magnitude of E is the same at A and B. We'll look at A and look at B. So if we take kind of an area here, how many lines are in this? 1, 2, 3 in this box. Well, let's make a similar box here. Okay, how many are here? 1, 2, 3, 4, 5. So A is nearly twice the strength as B, the electric field at it. So that's why this one is false too. This one was true, as you could see up there, we talked about. Q1 and Q2 have the same sign. Well, the arrows are pointing toward Q2 and away from Q1. This is positive, this is negative, so that's absolutely false as well. And a positive charge at A would accelerate to the left. Well, that's the opposite of this one right here. Yes, see, the arrows are pointing to the left. That's the way a positive charge would go, so that's absolutely true. The size of Q1 is larger than that of Q2. We'll count the lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 if I didn't miscount. So Q1 has 18 lines attached to it. Q2 has, and it's clearly less, but we can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 lines in Q2. So Q1 is definitely bigger. How much bigger? 18/12 bigger, which is a 1.5 times as big, if you want to call it. It doesn't ask for that, but it's 1.5 times bigger. So, all right, that's it. Awesome. That's a lot to digest, but give it a try. Think about it. Let me know.